Let's have a look at our next rule, the product rule.
Yes.
Now, that's the formal rule there. Again, not something I worry about. Where it's used is where you have two functions multiplied together. Write down the first diff the second, plus write down the second diff the first. Basically, the way I remember it is how you do it. So that as I'm writing it down, I'm saying it, and I get it in the right order then. So something like this, yes, I know I could expand it out. Problem with the product, where it's really going to become useful is once we know how to differentiate more functions, so log functions, exponential functions. And so when you've got them multiplied by each other, it allows us to do it. At the moment, of course, we're just stuck with polynomial type functions. So yes, I could expand that out, but let's pretend we couldn't, or we couldn't be bothered. Okay, so we'll differentiate it. Write down the first. Well, the first expression there is x to the power of 7, so I write it down. Diff the second. Well, the second expression is x to the power of 9 minus 6. Differentiate that, I get 9x to the power of 8. Plus, write down the second. X to the power of 9 minus 6. Diff the first. And differentiate x to the power of 7, we get 7x to the power of 6. And now we can tidy that up. We get our answer there, 16x to the 15 minus 42x to the 6. So write down the first diff the second, plus write down the second diff the first. Now, of course, it gets more impressive the quicker you say it. Write down the first diff the second, plus write down the second diff the first. Gotta say it quick, gotta say it quick. Okay, so again, yes, we could expand this out, but let's do it the other way. Write down the first, x minus 2. Diff the second, 2. Plus, write down the second, 2x minus 3. Diff the first, 1. Tidy it up, and we have our answer. So write down the first, diff the second, plus write down the second, diff the first. Don't worry about all this UV dash rubbish. Just complicates things that don't need to be complicated. Speaking of trying to complicate things that don't need to be complicated, look, I just thought I'd throw a few higher powers in there just to go, whoa, this looks a bit more complicated. But it's still just a product of two things, so write down the first, x to the 7 minus x to the 3, diff the first, second, sorry, write down the first, diff the second. 3x squared plus 7 differentiates to give 6x. Plus, write down the second, 3x squared plus 7, diff the first, 7x6 minus 3x squared. You know, when you think about it, using the product rule for this question's rather silly, because the reason I would have used it is to save expanding the parentheses out. But look at my answer. I've still got to expand out a binomial, so not always the most efficient method for something like this. But again, we are kind of restricted with the sort of examples we can look at this stage. Now it gets useful. I don't want to expand out x squared plus 4 to the power of 5, but where this is really good is we get to combine our two rules now. Watch this. Write down the first, 3x, diff the second, anarchy! Bring down the power, lower the power, out comes the 2x. Plus, write down the second, x squared plus 4 to the power of 5, diff the first, 3x differentiates to give 3. Now, tidy that up. I'm going to factorise it. Look, what do we got? We've got a common factor there of x squared plus 4. We always take out the lowest power when we factorise, so that'll be to the power of 4. And there's also a 3. I said there's also a 3. Why didn't I take out the 3? I said there's also a 3. Oh, eventually, there it is. Okay, 3 outside of x squared plus 4 to the power of 4, 11x squared plus 4. Now that certainly has saved us some time by combining it with our chain rule, our anarchy. Again, useful here because we can't expand out the 2x minus 1. So we've got two functions, put it in index form. Write down the first, 2x, diff the second, but to diff the second, got to use anarchy. Bring down the power, lower the power, put the boot in, get that derivative out of the parentheses, times 2, plus, write down the second, diff the first. You know, one of the mistakes I often see with this is, because you've done so much in just that first bit, the write down the first, diff the second, a lot of people just stop and think, I'm done. But no. Remember, plus, write down the second. diff the first. Okay. Again, we're going to factorise. Well, negative a half is the lower power, so it's the negative a half we'll factorise out. And gee, I'm really hoping we also factorise the 2. Yes. Okay, so the 2 came out straight away this time. And we're left with x plus 2x minus 1 to the power of 1. And that tidies up, of course, to be 3x minus 1. Mind you, well, mere mortal answer is probably back here somewhere. This is a little bit better than mere mortal, but it's still not super mathematician. There we go. 2 times 3x minus 1 all over the square root of 2x minus 1. That's a good answer. I guess it all comes down to what are you going to do with the derivative. So if you're then going to use it to find the slope of a tangent or something, depending on what I'm substituting in for x, this final answer is a better answer because I'll get it in its exact form straight away. Say I was subbing in x equals, or pick a number, any number except a half. 2, okay. So if we substitute 2 in there, then on the top of the fraction I'll get 6 minus 1's 5, 2 5's are 10, over the square root of 3. But I've got the exact answer straight away. Whereas if I'd left it the other form, I'm going to still have a power of a half. I'll go to my calculator. Oh, hang on, that's an approximation, not an exact value. So that's why I like to get them back into those surd forms. So 7F is our product rule.